home, I started taking pictures of those. It's like math terms.
Okay, so when you see the words find a particular solution, that is basically saying find your plus C. Okay? When we have a general antiderivative, we know that there can be an infinite number of antiderivatives that all are varying by a constant C. Okay, so that's why we write that plus C. Now, if we have some information about our original function, we can actually find what that C value is. Okay? But only if we have information about our original function. What do I mean by that? Okay. So in this example, I'm asking you to find f. I'm giving you f prime, which is 4x squared, and I'm giving you some information about f. We know that the coordinate -1, 3 lies on the curve. Well, we know that our function is the antiderivative of the derivative. Would you agree? Okay, so Amy, what is the antiderivative of 4x squared?
4/3 x cubed.
Plus C. Okay, so f of x is 4/3 cubed plus C. So that generalizes all of the antiderivatives for 4x squared. However, we know something about -1, 3. So what should we do with -1, 3?
I'll get -1 for f of x instead of equal to 3.
Okay. We can put in -1 for x, and we know that when x is -1, our function value is 3. Okay, so 3 equals -4/3 plus c, which means our c value for this particular solution would be so our function is 4/3 x cubed plus 13/3. Okay, so basically we are finding the antiderivative with our plus c, and then we're plugging in that original coordinate to solve for c. Okay, not too bad. All right. Write down this example. So I'm giving you that g double prime of x. So the second derivative of sine of x. G prime of 0 is 1, g of 0 is 6. Okay, please take a moment to discuss with your pod why did I give you 2 pieces of information this time? Talk about it with your pod. CJ.
I shall agree with that. Because you can't take a derivative or C.
Okay, so what do you think? Why, in this case, did I give you 2 pieces of information? Marcus, what did you guys talk about?
That you need to, because it's a double derivative, so you need one for the one right below it, which is normal derivative, and then all the way down. Start.
Okay, so what you're saying is we're going to have to go through this process twice to get to the function. Okay? I like it. So if we have the second derivative, then we have to first find first derivative, right? So the first derivative should be the antiderivative of the second derivative. Henry, what is the antiderivative of sine of x? Which one, negative or positive? Good. Okay. So g prime is negative cosine of x plus c. We now can use our initial condition. We know that when when x is 0, then our derivative is 1. Okay, everybody, what is the cosine of 0? I think that mumble was a 1. Okay, we'll find our energy, maybe not till next week. Is that kind of how you're feeling right now? Okay. So, C is 2. We can write that the first derivative of g is negative cosine of x plus 2. All right, that's all fine and dandy, but what we really want is g of x. Okay, so if we want g of x, we have to go through this process again. If we want g, then we need to take the antiderivative of the derivative. Okay, Trevor, what would our antiderivative be?
Negative sine x plus 2x
Plus c?
Yeah.
Do you work your head a little bit?
Yeah.
You are not wrong. Okay, but we're going to start with plus c. Okay. I gave you the initial condition that when x is, what was it, 0? Our function value was 6. What's the sign of 0? So C is 6. So yes, Trevor, g of x is negative sine of x plus 2x plus 6. All right, I'm going to give you one to do on your own. Let's see how you do. One, two, three, go. All right, do you agree with CJ's work? I'm gonna be really picky about something, CJ, and I would probably not take off in this particular problem for it, but I could in other problems. When you have an integral, make sure you put your dx or w or theta or whatever it is. Okay, that is important. Okay, still learning, not a big deal, but make sure you get into that habit. Okay, all right. So I have a Friday gift for you. You can start your homework. You have 15 minutes to start your homework. Some of you may even be able to zoom right through it. Okay, it's not very long. It's page 251, 35 to 41 odd, and page 312, 1 through 8. Sounds amazing. Twelve problems. 12 problems.